Okay, so in this way we compute the follow function. Okay, we iterate over every non-terminal, we check for every non-terminal, and then we take a production where this non-terminal B exists, okay, in the RHS. And suppose the production is of the form alpha 1 alpha 2 alpha k beta alpha k plus 2 to alpha n. Then what we do, we first compute. Sorry, I have made a mistake. So this is not follow, this will be first of. Okay, so any follow of B will be the initial follow of B union first of alpha k plus 2 to alpha n. Okay, and if this alpha k plus 2 to alpha n is nullable, then I can apply the second condition, that is follow of, if beta is nullable, then follow of m is a subset of follow of n, and hence I can add the follow of A to follow of B. So let me create a small examples so that it will be clear how we compute this follow function. Okay, so let z is x y z. Okay, z z is d. Then we have another non-terminal y as c, where c is a token, and y can be an empty, it can generate an empty string, and I have x as a and x as b y e. Okay, so I have 6 productions. Okay, now let us try to create this table where I have non-terminals in the left hand in the row, that is suppose z, z or y or x, and in the column side I have 3 functions. One is called nullable, one is called the first, and the second is called the follow. Okay, so first I'll compute nullable. So what will be my nullable of z? So nullable of z is false because it cannot generate an empty string. You can see here z can either derive, so from this production, so the first so it can z is d, so it cannot generate an empty string. In the second, in the first production z as xyz, we have uh, again x is generating b or a, so I cannot so the non-terminal z cannot generate the sequence, cannot generate an empty string, and hence nullable is false. Okay, for y it can generate an empty string, so y by this rule, and hence it is true. For x it is false. Okay, now let us try to calculate the first function. So the first function for z, for z, y and x will be, so you'll iterate. Okay, so in the first iteration what it will be, so the first set will be 5, so initialization will be, all will be 5. Okay, in the second iteration what will be my first of z? So I can say first of g is what? First of g is, I can means blindly copy the d into the set because it has nothing. And for xyz I can say that if x is nullable, then it is so x is not nullable, so it will be first of z will be, first of z is equal to first of xyz. Okay, if xyz is nullable, uh, if xyz is not nullable, okay, and if xyz is nullable, then first of x, if x is not nullable, okay, and is it first of yz if x is nullable. Understood? But we have already seen that x is not nullable. Okay, so we will just blindly write first of x as first of z. Okay, now what is first of x? Now first of x is again what? So first of x is, will be a, or it will be b. Understood? So I can, from the second production it will be b, the first so from this production I can say that first of x is b, okay, and I'll put b, and from here I'll say first of a will be a, so this is by, and I'll combine that and it will be ab, and I'll take this ab and put it in first of z. So first of z will be d comma a comma b. Okay, what will be first of y? First of y will be first of c, okay, and that is c. What will be first of x? I have already told you. First of x will be what? It will be a comma b. Okay. Now try to, so let me copy that thing into a new page to calculate the follow function. Okay. So I have till now, so this is nullable, this is first, this is follow. Okay, and we have z, y and x, where it is false, true and false, and this is DAB, this is C, and this is AB. Okay, now let us try to calculate the follow function. So in the first iteration, what it will have, so I can say that, so I have Z as X, Y, Z, and Z as D. Okay, from there, and in which another is, let me complete it, x as a and x as b, y, e. Okay, so I can say, so I'll initialize first. So in the first iteration, what I'll do, the first step is I'll initialize it to empty set. So this is my z, this is my y, this is my x. Okay, now I can say that nothing can follow z, because in the grammar, because the other part of the grammar is y is c and y is epsilon. In the RHS side we are having this z, okay, but it is in the rightmost side and it cannot follow anything. So I will say that follow of uh, nothing is following z. So I can say that the follow of z is empty. Okay, now for y I have two RHS uses, that one is this one and another is this one. Okay, now suppose I have xyz, xyz. Okay, and what will be my follow of y? Follow of y will be, it will be follow of y union first of z. Okay, and what is my first of z? First of z is this is equal to d a b. Okay, and if z is nullable, no, but z is not nullable, so I would have added the follow of z into follow of y, but z is not nullable by the algorithm. Then I will take the second production. Suppose z as b y e. Then what will be my follow of y here? Is equal to follow of y, already I have calculated, union first of e. So I will just add the symbol e to a b e. Okay, so I'll put it, so I don't have any further RHS uses of y, right hand side uses of y. So from these two productions I can say that follow of y can be d a b e. Okay, now let us try to calculate follow of x. Okay, now follow of x will be, so we have two rules, so z as x y z, and I have z as and follow of x anywhere else, no, so I have a single uses. Okay, so I can say that follow of x, I'll first take what it will be, first of, it will be follow of x union first of yz. Okay, now what is first of this yz? So first of yz, but y is nullable, you remember. Okay, then which rule we should apply? It should be first of y union first of z, since since y is nullable. Okay, and hence we get first of y is what? C, and first of z is what? D A B. So it is C D A B. So in this way, after more iterations also it will get the same stable values, and hence this is the final value of follow of any non-terminal in this grammar. Okay, so using these three things, that is first, nullable and follow, we can create a unique parse table, okay, in predictive parsing. So that was the final aim. That means given a non-terminal, so let me go back to the first class where we have taken the steps to create a bottom top-down parser. We have created task for every non-terminal. You remember? If you remember, I have created, so every non-terminal, suppose t as a y, I have created a task or a function called parseT. And in this parseT, the main objective was how to select a possible production. Okay, how to, out of multiple productions, how to select a possible production, how to select a production given a input token. Okay, next input token. So for that we have done all these things. We have created the first function, we have created the nullable function, and we have created the follow function. So let me do it again. Let me reiterate this example again. Okay, so I have this grammar ready. It is x y z. Then I have, so it is an example one. I have, say, z as d. I have y as c. I have y can be empty. I have x as a, and I have x can be b y e. Okay, now we have also created the table. So the table looks like, okay, and here it is null, nullable, the first and the follow. For Z it is false. For first it is suppose D A B, and for follow it is empty. Okay, for Y it is true. The first will be C, and what will be my follow of Y? Follow of Y we have calculated as D A B E. Okay, and for X the nullable is false, and the first of X was AB, and the follow of X contains C D A B. Okay, now with this much information we can, the aim is to create a predictive, what we call as a predictive parse table. Okay, that means we can predict correctly based on the current function we are in, whether it is parse t, that means the current non-terminal we are in, and what will be my next input token. Okay, so the predictive parse table looks like this. So you have a matrix, two-dimensional, where the rows are matrix, or you can say it is an array. Okay, two-dimensional array where the rows is Z, Y and X. Okay, and the columns are the possible input tokens present in the grammar. Okay, so I have A, B, C, D and E, and the job tells, and the table tells me when I am in a given non-terminal and my next input token is this, out of this anything, then which rule I need to select. Okay, and that makes my, and that was my aim. Okay, which rule I need to select, which production I need to select. So let us see. So the claim is, so if a token T, so for row X and column T tells the parser which production I need to execute, which part we need to execute in function parseX. Okay, so which path we need to take in parseX. Understood? When the next token is T. So clearly if T belongs to first S, okay, so suppose I have X is equal to S, okay, I can select this production if T belongs to first of S. Okay, then enter XS in the row X and column T. Okay, so suppose I have Z, oh, Z, sorry, so G is XYZ and Z is D. Okay, then for a input symbol A, okay, so A belongs to first of Z, and hence I can say that I can apply the rule Z as X, Y and Z. Understood? Because first of XYZ is what? A. Okay, and suppose you get an input token D, then since D is the D is the in first of D, so you can say that you'll apply the production Z is equal to D. Okay. If you get input symbol B, what can happen? So B is also present in Z is XYZ. Okay. Then I can say that for B also we need to select X, Y and Z. Understood? So first, so you see what will be my first of XYZ. First of XYZ will be first of X, and first of X is A comma B. Okay. So if you get either A or you get either B, then you'll apply the rule Z is XYZ. Okay. If you get a D, then you will apply the rule production Z is D. Okay. Z arrow D. Similarly for Y, what can happen? Remember, Y is a nullable thing, so we need to do it carefully. So if you get a for Y, it can generate an empty string. So I can apply the rule is empty. Okay. If you generate B, then you can apply the rule Y as empty. For C, you can apply the rule Y as C. For D, you can apply the rule Y as empty. And for E also you can apply the rule Y was empty. For X, you have a rule X is equal to A. So you can blindly say that X will be A. Okay. For B, what can happen? So you have X of the form B, Y, E. Okay. And so if you get B, then what will be first of B, Y, E? First of B, Y, E will be B. And hence, uh, you'll apply X as B, Y, E. Understood? Then for C, D and E, we cannot do anything. So these are the blank areas. Okay. And these are meant for, so whenever you are in a function corresponding to a given non-terminal and you get a next input token, suppose for Z you get a next input token as C, or you are in X you get a next input token as C, then that will be syntax error. You have to report that it is a syntax error. Okay. So in this way we create a predictive parse table, and using this parse table we compute, we take decision as to which production I need to take at a given point of time. Okay, thanks.